What if everything you see, touch, and experience is just a projection, like a 3D movie playing on a cosmic screen? What if the vast infinite universe isn't out there at all, but encoded on a flat two-dimensional surface? This is the startling concept behind the holographic universe, a theory that suggests our reality might be no more real than the pixels on your TV. But here's the twist. This isn't just science fiction. Quantum physics and cosmology are uncovering evidence that could make this idea a fundamental truth. And if that's the case, are we living in a simulation governed by rules written into this holographic fabric? If the universe is a hologram, who or what designed it? Today we'll journey deep into the holographic universe, its implications for simulation theory, and what it could mean for your reality. By the end, you might never look at your life or the universe the same way again. The holographic universe theory is as mind-bending as it sounds. Imagine a world where everything, planets, galaxies, even you, is a projection of information stored on a two-dimensional surface. This concept stems from the holographic principle, first proposed in the 1990s by physicist Gerard de Hooft and later expanded by Leonard Susskind. The theory gained traction when scientists studying black holes noticed something strange. The amount of information a black hole can contain isn't proportional to its volume, but to its surface area. This means that the stuff inside a black hole could be encoded on its boundary, a flat 2D edge. Now apply this to the universe as a whole. What if the entire cosmos operates under the same principle? What if every particle, every law of physics, and every moment of your life is just a projection of encoded information? This concept doesn't just stay within the realm of black holes. It's linked to cutting-edge physics, including quantum mechanics and string theory. Some even believe the holographic principle aligns with the simulation hypothesis, the idea that our universe is an advanced, programmed simulation. Why does this matter today? With advances in quantum computing, artificial intelligence, and space exploration, we're closer than ever to unraveling the fabric of reality. If the holographic universe is real, it could redefine our understanding of existence and raise profound questions about the programmer behind it all. But if reality is encoded on a cosmic surface, how can we be sure? That's where the challenges begin. If the universe is holographic, how can we prove it? The idea is elegant, but science thrives on evidence, and testing this theory comes with challenges. One issue is scale. The holographic principle applies easily to black holes because their boundaries are measurable in theory. But applying it to the universe means dealing with cosmic scales that are almost unimaginable. How do you measure the edges of the universe when we don't even know if it has boundaries? Another challenge lies in perception. Our senses and tools are designed to perceive a 3D reality. If the universe is a projection, everything we see, hear, and feel is part of the projection. How do you step outside the hologram to observe the surface where it's encoded? Then there's the issue of implications. If the universe is holographic, then space and time as we know them might not exist. The smooth flow of time could be an illusion, and distances might be meaningless. This challenges not just physics, but also philosophy. What happens to our sense of self and free will if we're part of a projection? Finally, consider the creator's intent. If the holographic universe supports a simulation theory, it implies there's a programmer, an architect behind the cosmic code. Who or what designed this system? And for what purpose? The absence of clear answers leaves us grappling with the most profound existential questions. These challenges are daunting, but they're not insurmountable. As technology and science progress, the holographic universe might shift from theory to fact, and the journey to understanding it is just as fascinating as the implications. To explore the holographic universe, let's consider its connection to simulation theory. If our reality is a hologram, it aligns perfectly with the idea of a programmed simulation. After all, a hologram is a digital construct, a projection of encoded information. One of the most compelling pieces of evidence comes from quantum mechanics. In 2015, researchers conducting experiments on entangled particles noticed that their behavior could be explained if space-time itself was quantized, divided into tiny, discrete units. This suggests that our universe might have a resolution limit, much like a computer screen. Then there's the work being done in string theory. This theoretical framework proposes that the fundamental particles of the universe aren't points, but vibrating strings. These strings operate under mathematical rules that resemble a coding language. Some physicists, like James Gates, have even found error-correcting codes, similar to those in computer programming, embedded in the equations of string theory. But why would the universe need to be a simulation? Consider this. Civilizations in advanced simulations could program countless realities for experiments, entertainment, or understanding their origins. If our universe is holographic, it might be just one instance among billions. The implications are staggering. If the holographic principle is true, it suggests that the universe isn't infinite but finite, encoded with a set amount of information. This doesn't limit its complexity, just as a DVD can hold an entire movie. But it does challenge our assumptions about space, time, and reality itself. Still, one question looms. If this is a hologram, what lies outside of it? Here's the breakthrough. Experiments and theories are converging on evidence that supports the holographic universe. In 2017, researchers at Fermilab conducted the holometer experiment designed to detect quantum jitter in space-time. They aimed to find out if space itself behaves like pixels on a screen, discrete and limited in resolution. While the results were inconclusive, they paved the way for future tests that could confirm or deny the holographic nature of reality. Meanwhile, advances in quantum computing are revealing just how much like a simulation our universe behaves. Quantum particles don't exist in definite states until observed, much like pixels on a screen that remain inactive until lit up. This observer effect could be a hint that reality functions on demand, just like a computer program. But the most compelling argument might come from the sheer improbability of our universe's fine-tuning. From the exact strength of gravity to the precise configuration of atoms, everything seems perfectly calibrated for life to exist. If we live in a holographic simulation, this fine-tuning might not be coincidence but design, a deliberate choice by the programmer. So, what's the next step? If this theory is true, what lies beyond the holographic surface? And if we discover the truth, will it change how we live within the simulation? The holographic universe challenges our understanding of reality at every level. It suggests that everything we know, space, time, matter, isn't as solid or infinite as it seems. Instead, our reality might be a projection of encoded information, like a cosmic 3D movie playing out in front of us. We explored the origins of this theory, from black holes to quantum mechanics, and its implications for simulation theory. The evidence, from error-correcting codes to the fine-tuning of the universe, supports the idea that we might be living in a designed, programmed system. This concept isn't just theoretical. Ongoing experiments like Fermilab's holometer and advancements in quantum computing are bringing us closer to proving or disproving the holographic principle. If confirmed, it will redefine not only science, but also philosophy, forcing us to confront profound questions about existence, purpose, and the nature of reality itself. But for now, the mystery remains. We're left to ponder whether we're players in a grand simulation, guided by rules written into the fabric of the holographic universe. What do you think about the holographic universe? Are we living in a simulation? And if so, what lies beyond it? We'd love to hear your thoughts in the comments below. Share your theories, ask your questions, and let's unravel this cosmic mystery together. Don't forget to like, subscribe, and hit the bell icon to stay updated on our latest explorations into the nature of reality. And if you enjoyed this video, check out our deep dive into pixel theory or the simulation hypothesis, because the answers might just be hidden in the code. Thank you for watching.